This is Shahine Bouabid for the encode AI Fellowship application. Climate change is already here, and we are already experiencing some of its effects, such as prolonged heat stress and floodings. Now, a big question remains, among the myriads of possible futures, which one are we going to follow? And most critically, when we're planning for long-term decisions, long-term infrastructures, what are going to be the associated physical risks that might impact our food production and our ecosystems, for example. The way this is diagnosed today relies on two streams of data. One are the simulation data from the so-called climate model, which tries to project what the future will look like, but at the cost of very long and expensive simulations. The other are Earth observation, which we only have for our lived present, but that help better constrain the future. Now, turning this data into a future risk assessment is a very long process by the computational cost of these simulations, but also because we are dealing with just petabytes of data that require expertise to process and analyze. I think in this context, generative AI stands as a fantastic opportunity to streamline all of this. First, because it's a lot cheaper to evaluate than running a full course simulation, which might take months versus seconds here. But also because once we have the AI set up, anyone without advanced climate expertise should be able to use it to meet its own needs in terms of risk assessment. And I'm going to demonstrate to you like a quick tool that I've already built around this that uses generative AI to reproduce climate simulations at a fraction of the cost. So there's a GitHub repository for this tool called ClimeMU. Instead of just describing it, I'm actually just going to show you. There's a collab notebook which you can follow here and like just open it at home and try it for yourself. I've preloaded some of this for the purpose of presentation, but say that I wanted to see what the climate may look like in the future at plus 3 degrees of warming, and say I want to do this in April, so I choose month 4. And that's all it takes. I am running now this generative AI method in the background, and as you can see, it's not instantaneous, but this is taken seconds compared to weeks or months of compute we would have needed to roll full course climate simulations. Right. Once I have all of this data generated, then I can just use like an existing agent. So here I'm just compiling it into a full data set, and I can just ask Claude or ChatGPT to plot whatever I'm interested in out of this data set. Here, say I'm interested in looking over the Mediterranean region. What will the climate look like? And so this is what I've generated, and I'm looking at, and here we go. This is like the warming in temperatures, where we see that the land warms faster than the sea. This is for precipitation, where like the brown color indicates a regional drying. And we can basically do this for any climate variable that might be relevant for our risk assessments. This corresponds to humidity, this corresponds to wind speed, etc. I'll stop here because I think it's 3 minutes already. Thank